Hi, welcome to my channel. And continuing with the remote power monitoring project, I now have to build the adapter board for the XB that will be the transmitter, and this is the board that will eventually go inside of the kilowatt meter. So there are some modifications. It's not just a straight build of the adapter board. We are going to be tapping off of the kilowatt meter for power, and the 3.3 volt regulator that the XBs run on, when this is transmitting, to help maintain the voltage, we're sort of using this large capacitor here to help maintain that 3.3 volts, because it does use, I guess it does put a strain on that little 3.3 volt regulator. So let me get started on this, and then the next step will be opening this up and starting to connect this new adapter board, or this additional adapter board, into the kilowatt meter. So this is the adapter board kit. And then this is the mod kit, I guess you could call it. This is the accessory kit for the additional parts you need for installing it into the kilowatt meter. There's that large cap there I was talking about. So the first three components I'll solder in is the 3.3 volt regulator and C1 and C2. And we'll clip these leads out. So this is the first mod of the XB adapter board. We're going to go with a larger green LED and leave the leads a little bit longer, because eventually we're going to drill a hole through the top here, and this LED will be poking through that hole and indicating that this is transmitting. So that's the first change, as we're going with this larger green LED. So I've got the components in, I got the leads spread so they don't fall out. Just turn this over. Make sure you have the correct polarity with the LED. The shorter lead is the negative, the longer lead is the positive. Clip those leads off. So next I'm going to solder on these two female headers, and I'll get back to you. I won't bore you with all these soldering all these pins. So I have the female headers on, and at this stage I'm going to set this aside, and I need to work on some wiring that we're going to use to install that adapter board into the kilowatt meter. You get this ribbon cable with the kit, and I need to separate the, let's see, brown, red, and orange, and then the black and the white, and the green wire separate. Need a separate green wire. So I have to separate the brown, red, orange, and yellow. Let's see if I can do this. Just get that started, and then you can just tear that down and separate these. Like so. And then I need to do the same with the black and the white. that just tears down. And I need to separate, I need a single green wire by itself. So I'll remove that one. So these are the wires I need to work with in the next step. So to start with the green wire, I only need about 1.5 inches, and then I'll strip off 1/4 inch from each end and tin them. So now I just want to tin the ends of these wires. I want to get that glob off of there. So this is the actual schematic of the circuit trying to complete for the transmitter portion. And if you recall, the adapter board gets powered by the USB cable for the receiver when it's plugged into the PC or the laptop that I have. But this here is going to be getting its power from the kilowatt meter. So we're going to tap off the kilowatt meter, and remember the XB module itself runs on 3.3 volts. So we've got the regulator, and we've got some larger capacitors here to help maintain that 3.3 volts, and we have some jumpers that we need to install along with these resistors. So the first one, that green wire goes from VREF, it's going to go up to VCC, which is up here. So that's the first jumper that gets installed here. So that's where that green wire is going. It's going from pin 7 here on the right all the way up to pin 1 here. And again, all this detailed information is available at the ladyada.net website concerning this. They're calling it a tweetawatt, remote monitoring or sensing of power from the kilowatt meter. So let me go ahead and solder that wire in place. Next, I've taken this ribbon cable that we created by separating it from the other strands. This has the brown, red, orange, and yellow, and I've separated the ends about, I don't know, about 1.5 inches. So they're all separate and not together. And same process. I've stripped and tinned about 1/4 inch off of the ends on both sides. And now I'm going to solder a 4.7K resistor to the yellow wire on this end here. So I'll cut back this resistor so it's a short lead, and before I solder it, I'll put, I don't know, 1/2 inch of heat shrink on the yellow wire, and then once it's soldered, slide that up and shrink it. So the first thing, I'm going to tin this shortened lead on the 4.7K resistor. The yellow wire is already tinned. So let me just slip this heat shrink over the yellow wire, and then go ahead and see if I can keep this steady enough. Then slide the heat shrink up, and you can use your soldering iron, or if you have a hot air gun, use a hot air gun. I happen to have a hot air gun. And that shrinks right up. So I've gone ahead and finished this part of the assembly. A lot of things are crammed in here. There's essentially two voltage dividers. There's one here and there's one here. And there's this 220 microfarad electrolytic capacitor that was added also. Let's take a look at the schematic. So this is the 220 microfarad capacitor that was added. And this is essentially the two voltage dividers. There's this one here, it's a 10K, the 4.7K resistor on pin 20. And over here, there's another 4.7K and 10K resistor on pin 11. Next, we have to add this 10,000 microfarad capacitor and this diode. This is what's feeding off of the 5 volts from the kilowatt meter. And this is the 3.3 volt regulator. So that's it. I need to add that, and then I can start tapping into the circuit on the kilowatt meter. And I get to see if this works. So this is the 10,000 microfarad electrolytic capacitor, and all electrolytics have polarity. And you can see here, this line here indicates the negative lead. It's also the shorter lead. But I need to keep track of this line here because I'm going to be shortening these leads so they're pretty much the same length. So that's how you would determine which one's the negative. It's this line here with the negative symbol. So let me put this in the vise so I can start soldering to it. So you can see from the schematic, this is the red lead coming off of the adapter board and the 3.3 volt regulator. That's going to go to the plus side of the electrolytic, and then the cathode of the diode is also going to this point. So it's hard to tack to both the diode and the cable there without one falling off while you're trying to tack on the other. So I'm going to put a little hook on the capacitor, and then I'll be able to hook the diode and the wire and crimp it down so it's secure, and then be able to solder it. So this is the plus lead. I'm just going to put a little bit of a hook in this, like so. Then I can take the red lead, put a hook in that, and it'll stay because I've tinned these, so it's a little rigid. And then there's the diode also. Let me move the schematic out of the way. I've lost the diode. Here it is. So you can see there's the line indicating the cathode on the diode. And I want to shorten this, just shorten this a little bit. And I'm going to put a hook in this also. Clip that on. And I can crimp both of these. Now I don't have to worry about that falling off. So let me solder that. If this was just tacked on, each one of those would fall off when I reheated. I'd just be going in circles trying to get both of them to stay. So the white wire went to the anode of the diode, and I've got this heat shrink I want to cover everything up here with. See if that fits. There it goes. So I'll shrink that. That's a nice neat look. Now the other side, there's a black and a brown wire that goes to the negative side of the electrolytic, and I'm going to just pigtail these. It's just take these two wires, twist them together, and I already put a hook on the negative lead of the electrolytic, and I'm just going to put a hook in these. Oh, guess what I forgot? I forgot to put my heat shrink on. This little piece of heat shrink I want over both of them. Actually, that's right, I could have gone ahead and put that on. So I'm just going to twist these. Put the heat shrink over first before I solder. And then take this twisted pair and put a hook. Maybe I think I'll tin those two now that I have them twisted together. And now I can put a hook in these. Hook it up to the capacitor here. Crimp that down. Got a nice mechanical connection and a good solder joint. That's not going anywhere. And now I can slide the heat shrink and now I can just shrink that with the heat gun. That's a nice, neat looking harness here. This harness assembly, I guess you can call it. So now we have these 4 leads which tap into the kilowatt meter when we open it up. You got the white, the black, and the yellow and orange. So let's go ahead and open up the kilowatt meter. So just a quick disclaimer here. I'm doing this project on my own. I'm not recommending anyone else do this. It's always dangerous to go in and modify an existing appliance on your own. Unless you feel comfortable doing something like this, I wouldn't recommend it. So I'm going to open, of course, also, you don't want to work on something like this when it's plugged in. So it is not under power. So let me open this up. So let's take a look inside. It's just 3 screws, it looks like. It comes apart easy. There's the 3 screws. Put them in there. And that's what it looks like. So this looks a little different than what's on the website for this project. There's supposed to be a chip, a leaded chip right here. There could be a surface mount one on the other side. So I think I have to take this board off and take a look. I think I have to take the board out anyways because I have to drill a hole and I don't want to hit this board. So, is that all the screws? Looks like it. Let's see what's on the other side here. Whoa. Where's that chip? Looks like things have changed. Uh-oh. Oh, there it is underneath the LCD display. That just has this contact material that hits all these pads here. So, I think that's the chip right there. I was getting worried, I couldn't see it. So this is a little bit different. This is a surface mount chip. So this is actually a Texas Instruments 2902, a quadruple op amp. So I just looked up the data sheet on this, and I'll go ahead and start soldering the wires to it. So for this particular kilowatt meter with the surface mount LM2902, you really need a good magnifier in order to get in there and solder to those leads. They're just so close together, and a good fine tip soldering iron. It's pretty difficult. At least two of the wires went to pins 1 and 14, which are on the outside of this package, so those are a little bit easier to do than the two that were on the inside with leads on either side. So now I just need to reassemble this if I can. Let's see. Got this LCD display here. I think that just fits. I think this goes in first. The top part here, there's a conductive gasket that has slices in it that keeps them, each individual section is separate. And they just line up with these contacts. So I have to be able to have these wires come out from underneath here. So now I have to drill a hole for the LED. So we just used some double-sided sticky tape. And let's see. And the XB just goes right in here. I need to configure this for transmitting, I think. I need to hook this up to the laptop. So I have the receiver plugged in, and I've reassembled the kilowatt meter with the transmitter in it. And without going into detail, I followed the procedures that are outlined on the Adafruit website. But it's not a nice, neat package that you can follow to get this to work. There seems to be, when I set the transmit time on this, there seems to be an issue with it locking up, going into sleep mode, and I found on a forum how to go about resetting. So I think I'm transmitting too long of a time, and it dims the display, even though we have that large capacitor in there. So I have to look into that. But I do have it transmitting, and it is collecting data in the console of the XCTU software. So let's take a look at that. So I'm just going to plug my light into this. I have an extension cord here. Plug that in. And it doesn't power up until you plug something into it. So there's the light. You can see the display there very dimly. Starts to build up a little bit. seems to fluctuate and it goes out. And let's see here. You can see it's starting to transmit. Let me turn one of these lights off. See that? And the red LED is on here when it's receiving data. So that flashes. So you can see when the green LED flashes, it's transmitting, and then the receiver LED, red LED, turns on. So I'm still getting familiar with this software. As you can see here, they have a little graphic up in the top left-hand corner here for open the serial connection or close the serial connection with the radio module. So if you close that, there's the data. And wait a second, and then there's more data. So I am collecting data from the kilowatt meter. And now it's just a matter of, I do not know Python, so I have to go over the instructions they have on the Adafruit website concerning Python to see whether I'm able to put it all together to get a nice graphic of the power usage from the kilowatt meter. But this is the raw data, and I just need to translate that into something readable. So for now, that's where I am with this kilowatt project. Feel free to subscribe and or comment, and hopefully the next video I'll have this completed with a nice visual real-time graphic of power usage from the kilowatt meter. So thanks for watching.